Efficiency in programming describes how fast or how much memory a program uses up. And lists are very efficient at some things, but not the most efficient solution for other things. So let's take a look at how lists are represented to understand what uses of lists are fast and which aren't so fast. Appending to a list, assigning a new value to an element of a list, and building a list comprehension are all very efficient uses of a list. The list representation was designed to make sure that these operations are fast. A good way to think about a list is that there's a block of memory inside of your computer representing that list, and all of the values are represented contiguously, which means that it's easy to jump straight from the beginning of the list to the fourth value, because if you know where the beginning is and you know how big each one is, then you can just jump straight there in one step. It's also the case that when Python represents a list, it leaves a little bit of room in that block of memory reserved for any added elements that come later. So when you append to a list, there's space there already to put it, and so even appending multiple times is a quick operation. Every once in a while, this extra space gets used up, at which point the list needs to be moved in memory to another place that's got more extra space. That takes a little while, but happens so infrequently that you don't have to worry about it much, and so you can think of appending as a very fast operation. Similarly, item assignment, where you're changing one of the values in a list, is very fast because you have a contiguous block of memory. You know where each element is based on its index. So you can change that 7 to a 9. You don't have to search for where to change it. You already know where the beginning of the list is. That means you know where the fourth element is, and you can change that memory just in one step. List comprehensions are also fast because Python sets up a bunch of blank spots for the list you're building and then fills them in. Or if it doesn't know how long the list is going to be in a list comprehension, then it just appends over and over again. But like we said, that's fast too. On the other hand, inserting into the beginning or middle of a list is slow. Slicing is slow because it builds a whole new list, and adding to lists is slow because that builds a whole new list. And whenever you have to build a whole new list, you got to copy over all the stuff that was in the old list. So let's talk about inserting first. Let's say you have a list already and you've decided that you want to insert a 9 right here. That means you got to move everything else over to make room for the 9, because the way lists work is that they're a contiguous block of memory with the elements in order. So that means you got to allocate this extra space. That's fast because you've already reserved some room for it, but then you have to copy everything over one step. And you don't have to write code to do this. You just say insert and it happens. But what Python's doing under the hood is a fair amount of work to make room for a place to put that inserted value. And inserting at the beginning of the list is the slowest of all because you have to move everything over. What about adding a list? Well, let's say you just want to add one number to the end of a list, but you do it with the addition operation, which always builds a new list. Then you can't just put the 9 there, because that would change this list. So instead, you have to build a whole new list where you copy everything here and put it all into a list. Even though you're only adding a one-element list to the end, you're doing it by copying over everything that was already in the list. So in order to illustrate some of these efficiency issues, I ran a little experiment about building long lists of perfect squares. A perfect square is a number that is equal to an integer times itself, like 1, 4, 9, and 16. Here is a function that takes in the number n and, using a list comprehension, builds a list of n perfect squares, getting each k for the numbers from 0 to n minus 1 and squaring each one. Here we use append to achieve the same result. We take in n, the number of perfect squares we want to put in a list. We start with an empty list. We append to it n times, and that gives us the same thing. I could also use assign by building a list up front that's full of zeros, and then going through the list and assigning k squared as the kth element in that list. Also fast. But there are also slow ways to achieve this same result. So using insert, I could have started with an empty list and n times inserted at the beginning of the list k squared. Now, this builds the list backwards, but it's still the same list of numbers, and instead of appending to the n, we're inserting at the beginning. But every time you insert, you have to move everything over. And here's a fifth way of achieving this list of perfect squares, which is to start with an empty list and each time assign s to a new list that contains all of what was in there before, plus this new perfect square. Using n is 100,000, so these are pretty long lists, I ran how long it takes using a list comprehension, and it was 1.5 milliseconds, really fast. Using append, a tiny bit slower, but not an interesting amount slower. Like, you can't tell the difference between 1.6 milliseconds and 1.8 milliseconds. So for most practical purposes, it doesn't matter whether you do it with a list comprehension or append. Assign is also very fast. It's kind of two steps. You have to build the list of zeros, and then you have to fill it in. So it's almost twice as slow, but still really, really fast. Whereas using insert, we have something that's 1,000 times slower. 1,470 milliseconds is 1.5 seconds. And using an add, where we build a brand new list each time, is another 6 times slower than that. So 6,000 times slower than using a list comprehension. And as n gets larger, the differences get even bigger as well. So for most practical applications, you can just make sure you're mostly appending, assigning, and using list comprehensions, and then you can use lists for all kinds of stuff. They're great data structures. But if you have a process that requires a lot of inserting or building new lists, then there can be alternative ways of representing the sequence that are better than a list.